All right, so hopefully you all have out worksheet 8 and worksheet 5 if we have any time to get there, okay? We're going to do the notes on 8 today. I'd love to have time to go do a couple examples off 5 of the applications, but we'll see. If we don't have time, I will get to 5 on Thursday, but there are some things you should be able to do on 5 now, okay? Did everybody pick up the homework check sheet on the way in? Okay, that's what's due Friday. There's not a quiz Friday. There's 2 more worksheets due on Tuesday that are on the quiz, but I had this thought that if I left it all due till Tuesday and we have 2 work days between now and then, no one would do anything on those work days, so it's due Friday. Part of it is. Okay, I'm sure it wouldn't have been you, but all right. Today we're going to talk about solving exponential and logarithmic equations. Okay. So the first property is typed wrong on your sheet, I think. The first is the one-to-one property of exponential functions. So this would look like this, guys. 4 to the x equals 8 to the 2x plus 1. Okay. This is the kind of thing where you are going to try to make these bases the same. If you can make the base the same, for example, this. Okay, if you can do something like that, then you can set the exponents equal. Does that make sense? It says if the bases are the same, then it should say b to the x equals b to the y if and only if x equals y. So this should be exponents. Everybody good what I'm talking about? I don't even think you read your notes, so just do the examples and you should be good. But just saying. All right. So here's the question that's written on your notes. We can rewrite these both as powers of 2 if we wanted, but could we just change the 16 to what? 4 squared? So you have to know your exponent rules. 16 as 4 squared means you're going to do what with 2 and the x? Multiply. Okay. So this is 4 to the x minus 1 equals 4 to the 2x. Now that one-to-one property of exponents says if these are the same, the exponents have to be equal. So we can write it like this. Subtract an x from each side. And I think we just get x equals -1, yes? So if we plugged it back in, we'd have 4 to the -2 equals 16 to the -1. 1 over 4 squared equals 1/16. Okay. Moving on. B. Okay. B is going to be less fun than you like. But this is circled because it's most definitely on the quiz. Okay. Because the questions we just did, the first one, you did that in Algebra 2. You didn't do this in Algebra 2 probably. Okay. Now, there's 2 ways you can think about this. This is an e to the x squared. Does everybody understand that that would be 2x? Same. What? You can do this as a u substitution. Okay, just a minute. You could say I'm going to let e to the x equal u. Sorry, didn't write that very well. This would become u squared minus 3 times u plus 2. Which would factor u minus 2 and u minus 1, okay? But I really prefer to just factor it with the e to the x, as it saves me a step. This is e to the x squared. When you write it like that, you have to be careful because you're really multiplying those, right? That's a 2x, okay? Minus 3 e to the x plus 2. If I can think about that, do you understand that that's an e to the x squared? E to the x times e to the x is e to the x squared, which is e to the 2x. Okay, and then you're going to factor minus 1 and minus 2 to get a plus 2 and a minus 3 in the middle. So I did the same thing. If you did it over here, you'd eventually have to since we substituted in as u, you'd have to put it back. All right, now you're going, what do we do next? Well, if we set this equal to 0, we get e to the x equals 1. We set this equal to 0, we get e to the x equals 2. Now what? How do we solve? We have to take the natural log of both sides, yes. Anytime there's an x in the exponent, we're going to have to take the log of both sides. I wish we'd done some of those before we did this question, honestly, but we're going to take ln of both sides. You could do log of both sides. It's not wrong, but look what happens when we move the x out front. What is ln of e? It's 1, right? If we had done log of e, we would have had to divide to get rid of it, okay? This is just 1. So guess what? X is the natural log of 1. Do you actually know what the natural log of 1 is? No. Guys, stop. E to what power is 1? So this is actually 0, okay? This problem, if we take ln of both sides, we move the x out front. ln of e is just 1. So we have x is the natural log of 2. Yeah, if you do that one, you're going to have to do an approximately, which is what those squiggly ones mean, 693. Thanks, Michael. All right, so we have 0 or 0.693. I will tell you right now, if you use 0.693 and you plug it back in here, scroll back up, do you think it's going to come out exactly 0? No, because we rounded, okay? Any questions? That was tricky. I hope there's one more example of that in a little bit. Okay, this is what I probably should have started with. When you have an x in the exponent, you just do what? Log of both sides, okay? So we're going to do log or ln. And then what? And then divide. Okay. Can we simplify how we type that in? We have log 19 over log 3. Can we just do log of 19 over 3? No. You can compact subtraction into division, right? But you can't shorten this up, okay? So you're going to take your calculator. Darn it, did I do that thing again? There we go. It didn't take me 4 times to figure it out this time. Log of 19, I clicked on the little pencil, divided by log of 3. Make sure you close the parenthesis at least on the 19. I got 2.68. I just want to show you once. If I do 3 to the 2.68 power, I get 18.996. Okay, that's pretty darn close to 19, right? But there's times when it's really off. It depends how big the number is and how many decimals you keep. All right. What do I always say first, guys? Use your Algebra 1 brain, right? So what is your Algebra 1 brain telling you got to do first on this question? Yes. So we get e to the 8x plus 1 equals 7. Now, you can take the log of both sides any form you want. What do you probably want to take? ln would be much nicer. And then this guy will move out front as an 8x plus 1. Okay, what if I made you get an exact answer for this? This is 1, right? So I have 8x plus 1 equals ln of 7. What 2 things are you going to do? Subtract the 1 and divide by 8. So the only way to get an exact answer for this would be to say the natural log of 7 minus 1 all divided by 8. There's nothing nice about it. So if you want to do the decimal, you can do the decimal here or anywhere later. ln of 7 is 1.946 if I go 3 places. So if I subtract 1, I get 0.946. And then if I divide by 8, just kidding. Anybody get 0.118? Okay. Again, if I do e to the power of 8 times 0.118 plus 1, and then I do a minus 6, I get 0.987. I don't get exactly 1, but we're close. We good? It does say round to the nearest hundredth, I guess, which would be 0.12, which would be even further off. I'll specify on the quiz. All right, no wonder you weren't writing anything down. Those are worked out on your paper already, right? All right. Ooh, what are we going to do here? We do not want to take the log of both sides because we can get an exact answer here, okay? Anytime we can make those bases the same, we want to do that, okay? So this is 3 squared to the x, and this is 3 to the 3x minus 4. What do we do here? Is this x squared or 2x? 2x. Can I just write it like that, guys? If I subtract 3x, so I get positive 4, that'd be pretty easy to type back in and check. All right, can I make 1/8 into a power of 4? Is 4 to some power 8? Not to any nice integer power, right? Okay, so what could I make these both powers of? 2 or 1/2? Yes. Do you want to make them a half squared and a half cubed, or do you want to make it 2 to the negative 2? You want to do 2? Okay. Right now, this is 1 over 2 squared. I'm going to do it in 2 steps because I don't want to lose anybody. And this is 1 over 2 cubed. Did I lose anybody yet? So because they're in the denominator, this is really 2 to the negative 2. And this is 2 to the negative 3. So how can I write that? Well, it's going to be multiplied, right? I'm going to go ahead and show my work. It's negative 2 times 2x minus 1 equals, over here, it's negative 3 times 11 minus x. Somebody be checking me. Did I make a sign mistake already? Did anybody else get 5? If you made this 1/2 and 1/2 cubed, absolutely. Yep. Because this one would have been 1/2 squared. And this one would have been 1/2 cubed. Yep, it's exactly the same thing. You get opposite signs here, but it's exactly the same answer. Promise. Okay? One more of these quick. What do you want to do? This time you can't do a 1/2 and a 1/2, right? So we do 2 squared. And what is this one? 2 to the negative 1. So then I get 2 times 3x minus 2 up there, which is going to be 6x minus 4. And over here, this just becomes what? Negative 4 equals negative 8x when I subtract 6. Anybody else get in a 1/2? We good? All right. Oh, yay. This is what we need to practice. Do you want to call this, would you feel better when it's a U substitution? No? Okay, then I'm going to rewrite it like this, though. This is e to the x squared, and this is 12 e to the x minus 54. Okay? So if whatever this is squared, I'm going to have, I kind of feel like you guys would be better with an U on this one. I'm going to write it over here. It would be 2u squared plus 12u minus 54. Okay, I'm just thinking about how to factor this. We have to factor, okay? And some of you don't know how to factor this to begin with. Oh, what did it? Can we take out a 2? Yeah. That would make life so much better. Okay, if I take out a 2, I still have an e to the x squared plus 6 e to the x minus 27. Now it's a little bit easier to factor. Can 2 ever equal 0? So we really can just throw that away. Okay. If we had done it up here, we would have had 2 times u squared plus 6u minus 27. What are factors of 27 that make 6? Positive 9 and negative 3. Okay, again, same thing. I'm just using e to the x instead of u, okay? Now, if I set this equal to 0, I get e to the x equals negative 9. This equal to 0, I get e to the x equals 3. What's next? Okay, this question on the quiz says solve exactly and to the nearest hundredth. Okay, the exact solution would be to take the natural log of both sides, and I'd have x equals ln of e, which is 1, right? Equals the natural log of negative 9. Comments from the peanut gallery? Not possible. The peanut gallery? That's old lady saying, apparently. That's what my kids always tell me when I say things they've never heard of. Okay. Take the log of both sides here, and we have x times ln of e, which is 1, equals ln of 3. There's your exact solution, the only exact solution to this question. Then if it said approximate solution, we just type ln of 3 and get 1.099, anybody? Or 1.1 to the nearest hundredth? Because it'd be 1.10, I guess. All right. The book does show an example, says you can confirm this by solving this algebraic or graphically, okay? So you could graph this disaster in y1 and see where it hits 0. But that's not going to give you an exact solution, okay? And on the quiz, it does say you need both. All right. Can I rewrite these as powers of 3? No? So I'm just getting, if you don't want to write this down even, you don't have to. But if I move the 2x out to the front, I'd have this. Why did I do ln? Good question. I could have done log, right? Doesn't matter. Doesn't matter. As long as you do the same thing on both sides, it doesn't matter.
If it doesn't matter, why does log of x over?
Say that again.
You said that, like,
yes, ln of e is 1. Log of what would be 1? What's the base here? Okay, so if you have an e in the question, use ln. If you have a 10 in the question, use log. But if you don't have either one, use whatever, as long as you do the same thing on both sides. All right, so the exact answer, can anybody tell me what x would be exactly? Okay, or just 2 ln of 9, right? You got to divide by both of those. Yeah, if I was typing it, I probably would have typed ln of 12 divided by ln of 2, of 9, I mean, and then I would have taken that answer and divided it by 2. I totally get you. But this would be the only way to write it as a single exact. Moving on. What about this one? Nope. Do not ln first. Yes. And rather, this probably doesn't come out nice, guys. I usually just leave this. Okay? Because if you round right here right away, then you're just rounding, rounding, rounding. Okay? I would just leave this, then do ln of both sides. Take the natural log of both sides. Do ln is not really a thing. Okay? ln of e. So then what do I have to do still? Add 6. So I get x equals the natural log of 9.3 over 2.4 plus 6. And again, you can use decimals along the way. I got 7.35. Anybody? Okay. Now how come sometimes there's ln top and bottom and here there wasn't? Here we divided before we took the ln, right? We just didn't actually do the division because we wanted to carry out as many places as we could till the end. All right. Sorry, did you need me to go back?
Why did we?
On which one?
Like, why didn't we?
Here?
Yeah.
You could have done, we had to do the ln of both sides right away. So then they both had a ln when we divided. Better? Okay. Do I need to do either one of these? You need me to do 7? Can I rewrite these as powers of anything nice? No. So unfortunately, this would be like log of 3, move the 2x out in front, equals x minus 1, log of 6. Ugh. At some point, this is just going to be an ugly decimal. I'm not going to make you do this exactly. I could. We'd have to distribute the log of 6, move everything with an x to one side, just like when we did inverses. Remember that fun? Yeah, we can just change this all to a decimal, okay? Log of 3 times 2. Log of 3, close parenthesis, times 2. So this is all roughly, I'm going to carry some extra decimals if you're okay with that. Log of 6 is 0.7782. So if I distribute that, I'd have 0.7782x minus 0.7782. Could you finish that then? I got 0.176x equals negative I don't know what that says. It's supposed to be a negative 0.7782. Anybody get negative 4.42? Okay. Okay. Your answer. Let's plug your answer and mine back in real quick. So if I plug mine in, 3 to the power of 2 times negative 4.42, and on the other side, I do 6 to the power of negative 4.42 minus 1. I got 6.056 times 10 to the negative 5th equals 6.059 times 10 to the negative 5th. So they're very close, right? Okay, yuck. Can I skip this one? Just do ln of both sides? I feel like we've done that one a couple times. All right. There is also a property called the one-to-one of logs, not just exponentials. These are your favorite. These were your favorite last year. You saw a question like this. Log of 2x plus 7 equals log of x. And you went, oh, yay, we just get to throw the log away. That's the one-to-one property. If you have a single log equal to a single log and they have the same base, then you can just throw them away, okay? That's only true when you have a single log equals a single log. Oh, guess what number 1 is? Not a single log equals a single log. Okay. Algebra brain first.
5/2.
No. Because it's very confusing, but this is what that means. So we need to do what first? Add the 1. Yeah, it was not clear. Then what? Divide by 2. Log base 5 of 4x equals 6. Now, I always taught this as now you need to rewrite. How do I rewrite that sentence?
5 to the 6.
Yes, 5 to the 6 equals 4x. Okay? But then I realized that none of the Algebra 2 teachers teach it that way. Most of the Algebra 2 teachers say the word exponentiate both sides. That means put a big 5 here. Because log base 5 of 5 is just 4x, and over here I have 5 to the 6. Is that exactly what we just rewrote?
Yeah.
We said 5 to the 6 equals 4x. I like my way better because it doesn't feel like I'm magically crossing things out. I'm just rewriting a log into an exponent sentence that I can solve. But I'm okay with either one, okay? All right, 5 to the 6, that's going to be a big number, isn't it? Equals 4x, so if I divide by 4, I get 3906.25, and that's an exact answer. Okay, so single log, okay, when you have a single log, not 2, not 1 on each side, but 1 single log, you either need to rewrite it as an exponent, or you need to do what they like to call exponentiate. It is. Okay, I think the issue is too many times students don't know how to rewrite it. And so they use the magic of exponentiating. Okay. Oh, there are 2 logs. Can we get it so there's 1 on each side? I think we got to move this log over here. Well, would we do that? Plus, right? Everybody good? And over here we just have a 5, a very big 5. Okay. We learned those rules for a reason. What were those rules? If there's plus, you can rewrite it as single log base 2 with a what? Yes, x minus 6 times a 2x, which we're going to have to distribute, right? Okay, still equals a giant 5. Now what? You can distribute. Can I rewrite at the same time? Will I hurt anyone's feelings? This is 2 to the 5th, yes? Equals 2x squared minus 12x. Do you see what I did? Just trying to take care of writing it so many times. Now, this is 32. I need to subtract it over here, maybe? 2x squared minus 12x minus 32, which seems like a really good idea to divide everything by 2. Factors of 16 that make negative 6. Okay. So I got x equals 8 or -2. Now, can you take the log of a negative number? No. Is it possible that a negative number still works? Yes. Guys, if the original question had said log of 1 minus x, then all kinds of negative numbers work, because 1 minus the -6 would be 1 plus 6, which is 7, okay? So don't think every time you get a negative that it can't work. But in this case, when we plug the negative back in, this would be the log of -8, which doesn't exist, and this would be the log of -4, which doesn't exist. So we're going to have to throw our -8 away, otherwise known as an extraneous solution. Woohoo! Your very favorite thing, right? Anybody lost? Okay. Single log equals single log, your very favorite. Answer? Drop the log and we get 4. Okay. Can we make this single log equals single log? What are we going to do when it says plus? Log base 12 of 2x equals log base 12. There I go, writing my L's different, sorry. Okay. Now, do we have to exponentiate? You could, but it would all cancel. All you're going to get is what? 2x equals x plus 7. X equals 7. The whole quiz were as easy as those 2 questions? Okay. It's not. Sorry. Oh, what are we going to have to do here? Okay, this plus needs to be 16x plus 2 times 20x minus 2 equals log of 319x squared plus 9x minus 2. Who thought up this question? I don't know, because we got to FOIL this together. Well, we can get rid of the logs now, right? Can we FOIL that together? It'd be 320. This is getting easier all the time. 320x squared plus what? I'll go ahead and write it out. Plus a 40x and a minus a 32x and a minus a 4. Did I do it right? 319x squared plus 9x minus 2. If I subtracted a 319x squared over here, and I subtracted a 9x, going to combine all those, and added a 2, okay, I get x squared minus x minus 2. Are you serious? Okay. X minus 2, x plus 1 equals 0. X equals what? -1 or +2. Is -1 going to work? It actually would be okay on this side. But right here, if you put in a -1, you'd get -14. And you can take the log of -14. And yeah, same thing here. So we get to throw that one out. Everybody okay? Those were really big numbers for really little numbers at the end. Yeah, I was going to say some grad student wrote that question just to amuse their professor. All right, what are we doing here? Distribute what? Okay, so you're rewriting first as a multiplication, right? And over here, we can rewrite as what? 8 times x plus 6. Now what? X squared plus 16x equals 8x plus 48 plus 8x minus 48. Did I do that? I subtracted 8 from both sides. Everybody okay? And subtracted 48 over there. 12 and minus 4, which makes the answers negative 12 or 4. Can't do negative because I have plain old ln of x here. So the answer would be 4, where the ln of 4 plus the ln of 20 equals the ln of 8 plus the ln of 10. If I'm just checking it, this would be 80, right? When I multiply those together. And this would be 80. Check. Okay. If you, for example, if it just said this, because you were, first thing you're going to do is square it, right? Okay. Or if it had said this, 3 minus x, then a negative number would work because the first thing you're going to do is take the opposite, okay? So it is possible that a negative works. I just, anytime I get a negative, automatically check, though, that it's going to work. Okay. How long will it take 50 grams to decay to 10? Which is the original amount? Okay, so a sub 0 is 50, and we want a to become 10. 50 e to the negative 0.00043t equals 10. Algebra? Divide. Which is 0.2, by the way. Take the ln of both sides. I'm just leaving it. You could make that 0.2. I'm just trying to leave it so you know where it came from. Then what? This is 1, so what is the only step I have left? Guys? You sound just like the video. I'm going to divide by this so that we get t. All right. So ln of 10 divided by 50, close parenthesis, divided by negative 0.00043. 3742.88. Anybody? So approximately 3,743 years it will take for this radioactiveness to decay. Guys, I'd really be happy if there was much less whispering. Okay. Use energy, magnitude 6. So we're putting the 6 in here. Okay, how do we work backwards? Subtract. $4.54. Then what? Good job. I don't know that that's going to be nice, is it? No, so I'm going to just leave it. Okay, now what though? There's only one log. Can we just get rid of it? No, what base is it? 10. So we can either exponentiate both sides, if I could write a big giant 10 there, right? And then this would all just become 0.37e on that side. And on the other side, you'd have 10 to that nasty, disgusting power. Which is the same thing as rewriting. So we need to type this mess in and then divide it by what? Yes. All right. And the energy level is really big most of the time on an earthquake, so this is probably a big number. 10 to the power of 4.54 divided by 0.67, and all divided by 0.37. I got 1614052. I'm going to round to 6. Anybody else get 16 million kilowatt hours? Okay. I just didn't divide until the end. That didn't do this, so you got a little bit. You got 16 million whatever, right? And change. All right. So this is what you need to be working on. Guys, please notice you have to go back and do some questions off page 167. These are all application problems, okay? Now, worksheet 5. I know we have less than 5 minutes, but did somebody look at worksheet 5? Yes. Andrew, you rock. Number 7. Oh, number 7 is actually a question you can use on the app. Okay. Ken and Barbie just started a college savings account for their new baby Bubba. Shh. They'll put $150 in per month, a savings account. That's your payment. That earns 8% compounded monthly. So N is going to be monthly for 18 years because we're going to keep doing this till Bubba leaves for college. I is going to be 8%. Present value is 0. Future value is what we want to find. That's where your cursor is going to go. And 12 and 12 for payments per year and compoundings per year. For this, for part B, after you find part A, okay, you're going to change payment to 0. You're going to leave your future value, whatever answer you got from part A. And you're going to leave everything else the same. Yes, pretend that says C per Y. Okay, you're going to leave those all the same. And you're going to say, what present value could I start with today? This is not a blank. This is the same the above. And you're going to find this present value that you could put in there today. So grandma wanted to match it, but she's afraid she's going to die before Bubba gets to college. So what present value could she put in today that would grow half the same? Okay, I want to go to 6. I know I don't have hardly any time. This is a half-life question, guys. The half-life of a certain radioactive substance is 14 days. What you need to know is that this means it only takes half every 14th. Write that equation down. It's off the yellow sheet, okay? So this one starts at 4,000. And you put in a 28, you put in 100, and the equation here is this. All right, so I'm gone tomorrow. You're going to watch a short video that reviews what we just did today. Okay? And then it's worksheet 9A. I just go through it kind of quick. And the rest is work time. And if you want to be working and not doing 9A, just ignore the video, okay? I'm okay with that if you know what you're doing.